This video is meant for Mrs. Rose's AB Calculus class on linear approximation. Alright, so sometimes when you're asked to approximate different values, you're not given an original equation, you are given different pieces of data. Here we have a coordinate pair. We know that we have the point -1, 3. From our first derivative, we know that our slope value is -2, and our second derivative is 5. But when we go to write our tangent line, we don't need that information just yet. When we're writing equations of the tangent line, we're using the formula y minus y1 equals m times x minus x1. And when we plug in our y value and our slope value, we are going to just simplify it a little bit to get y equals -2x plus 1. When you approximate the value at x equals -1.1, we say that h of -1.1 is approximately, and then we plug it into here. -2 times -1.1 plus 1 is approximately 3.2. Now, our second skill is determining whether the approximation of h of -1.1 is less than or greater than the actual value. And this is where the second derivative piece comes in. Since this is positive, we know that at the point -1, 3, this function has to be concave down. I also know that the slope is negative, so it's going to be decreasing and concave down. So our function's going to look something like that. And then we're going to have a tangent line. And our tangent line is y equals -2x plus 1. And here's our h of x curve. So when we use our second derivative to tell us what the curve looks like, at -1.1 on a graph, so we have, here's our coordinate plane, here's 3, here's -1. At -1.1, we might be right here. The approximate value is on the red line, and the actual value is on the blue line. So we can say that the approximation is less than the actual value. And we write our conclusion like this. In general, if you have a function that's concave up, whether it's decreasing or increasing, your approximation is going to be less than the actual value. And if the function is concave down, your tangent line or your approximation value is going to be greater than the actual value. This concludes my video on linear approximation. If you have any questions, please see me during cab morning or in class.